Let's talk about the atom now. After we actually got the difference between element and atom, now we go deeper, right, and focus on the atom. So that's each individual element inside a particular element. Each an individual. Let's focus on only one component of the element, right? Because the element contains atoms, and if you take one atom, let's see the general structure that all atoms have. Yeah. Okay. So let's we are going to do two representation of the atoms, right? It's going to come in two form. We are going to represent the atom diagrammatically, so we use a diagram to represent it, and then we'll also use the symbol to represent the atom for you to get the difference and know what we are dealing with. Chemistry basically at the low level, right, handles a lot of atom, talks a lot about atoms, so it's very important that you understand the basic structure of these components we have. First, let's actually talk about the basic components in an atom. So these are the basic components of the atom. You have to know that it's different from the basic unit of matter. The basic unit of atom is different from the basic unit of matter. So the basic components in an atom, we have electrons. Yes. So these are the basic components in an atom: electrons, protons, and neutrons. So there are three. The basic unit of matter. We also say there are three, right? The basic unit of matter, we say they are what? Atoms, molecules, and ions. Atoms, molecules, and ions, right? We'll talk about that. But among all the three, we are just focusing on an atom. So if it comes to an atom, right? The atom is made up of what? Contains electrons, protons, and neutrons. These are the three particles. The three particles that make up an atom. Okay. So you have to know that inside the atom, right? These things that we have inside the atom have locations that they have to be inside the atom. They can be anywhere in the atom. They can just be scattered. But then there are locations allocated for them, right? They have locations that they have where they actually how do you call it? Um stay inside the atom. Right? Something like their house, where they stay, where their location. When you go to the atom, where you find them. So the house for the electrons, right? Electrons are found on shells, right? These guys are on shells. So where they are located is a shell. So we'll talk about the shell when you are looking at the diagram. And then when it comes to protons, these two guys are in one house. They are in one house. They are located in one location, and that location is what we call the nucleus. Nucleus. So these are the locations. They are not the basic component, but the basic component are electrons, protons, and neutrons. But then we are trying to show you where they are located inside the atom. So if you go to the atom, you find electrons on the shells. So these shells are not basic components. They are just the ones that are holding the electrons. And we have the nucleus. That's where the protons and neutrons are. Okay, now let's go to the diagram representation of the atom. So yeah, this is a simple model of the atom, generally of every atom. This is a general structure that we have, right? So you can see the labels. So the shells are these circle things here, and the nucleus is what we have in the middle here. So the nucleus is at the center of the electron of the atom. At the center, that's where we get the nucleus. And we say from the previous slide that was nucleus, right? Contains both these two guys. So that's why you see the color green is there, color red is there. So the nucleus is at the center, and then the electron are the black dots. They are located on the shells. The shells are the circular thing. Right? So this is how a basic structure is. So each of these are electrons, 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 and then the protons are located in the nucleus, and the nucleus is the center component, the center components of the atom, and protons and neutrons are inside that. This is a diagrammatic representation of the atom, right? This is how you use, if you want to use diagrams to represent them, yes. So each of these are called what? Shells, right? The circles are called shells. If you don't come shells, you can also call them uh, orbits. So you can call them orbits, or we can call them what? Energy level. These will be terms that we'll be using. This elective chemistry, so we need to know these terms. So shells or orbit or energy level, we'll be using these terms for them. But as time goes on, we'll clearly understand the difference, and clearly understand why they are named so that we actually relate and then use them interchangeably as we want. So we have the shells, right? You can call them orbit or you can call them energy level. So if you come to the shell, there's a shell that is closest to the nucleus. This shell one, this shell two, and this is shell three. right? This there is one closer to the nucleus, there is one closer to the um second, there's a third one, fourth one, and they all house the electrons. And then the nucleus house the both the neutron and proton. Okay, so these things are counted. You can count them, the number of electrons, the number of protons, we can all count them. Okay, so this is a diagrammatic representation. And we say shells are also called orbits or energy levels. Yeah, so yeah, that's it about the atom. Now let's go to the symbolic representation of the atoms. For the symbolic representation, let's say the atom, one atom is X, right? The atom has parts, so I will label them. Yes, so you can say Azov. I don't know Azov. Uh, AZOF. So parts of the atom. Let's just label the parts of the atom. I don't have that as of. I just saw it and I just decided to just put it there. So then, so these parts, when you have an atom, right? When you're presenting it on paper or symbolically, it has four parts that are given to it. And then yeah. So this is the main X. The X is the atom, right? The atom itself, the atom symbol. So the atom symbol will be there. X is just representing any atom. So every atom, right, or every element has a symbol. Every element has a symbol. So when we come to this one, when we have the symbol is X in the middle, but then we have four main parts of it. So the first guy, this guy here, we call it the mass number. The mass number. What is the mass number? So the mass number, we talk about neutrons, right? So we talk about electrons, we talk about protons. So the mass number, right, is the number of all. So the mass number is this. If you say n is the number of neutrons, right? And then let's say p is the number of protons. So if you take n plus p, if you go to the nucleus, right? The nucleus, whatever you find in the nucleus, the number of everything that you find inside the nucleus, right? That's what we call the mass number. That's what we call the mass number. So everything that you find inside the nucleus, right? You count everything mass number, but we know that the nucleus contains what the neutrons and then what the protons. So when you say at mass number, is there the sum of the neutrons and protons inside the nucleus of an atom? Is the sum of the neutrons and protons inside the nucleus of an atom. So you have the mass number at the top. That's what we call it. Usually we usually use A for it. So it's a convention that is used mostly. So that I'm also using that for you, so that you don't get confused. But A is what we use for mass number. If not, I will have used another letter, but that's a general distance so that you don't get confused. So mass number is A. Then the Z, so here's the count of the P. That's the proton number. Just count the number of protons. Z is for number of protons. Yeah, me too. I don't know why it's P. I don't know why Z is not P, but that's just a general conform a thing that people use, right? So um this is it, right? So the number of protons is what if you go to the nucleus. So this part are all talking about the nucleus. If you go to the nucleus, both neutrons and protons will give you a. If you go to the nucleus, right? Well, only if you count only the protons, right, it will give you the Z part. So P is the number of protons. That's also this side of the this thing are all about the nucleus. Okay. Now let's go to this part. Let's go to this part now. So the upper part, right, we are going to call oxidation number. So oxidation number or charge. Oxidation number, oxidation number or charge. Or valency, right? So there are atoms that you have X2 minus somewhere. We'll be meeting these things ahead, right? This is the oxidation number. You don't have to worry about the 2 minus or whatever like that, right? We'll talk about them basically understanding this when we are talking about ions, how ions are formed, right? Yes. So usually sometimes if it is zero, if the number that's at the top, the charge over there is zero, you don't really write it, but the charge is zero. If you don't write anything there, then it is just zero. Oxidation number is zero. Now the last one, the down one here. What is this down one? Down one is the frequency of the atom. Frequency of the atom. So if I have H2, H2, you see that at the bottom here, we have subscript here, we have 2, right? So the frequency of hydrogen here is 2. That's what we talk about. So the frequency are here. If you go to water, the water is H2O. What the frequency of hydrogen? So this one atom Is another atom, oxygen atom coming together. If you look at the hydrogen, right, the subscript here is 2. So the frequency of hydrogen in water is 2. The frequency is the number of the atom, the number of a specific atom inside a compound on an element or whatever. The number of times that particular thing appears, how frequent it appears. That's what we call the frequency, the F, right? Yes. So yeah, this part is all about that, right? This is the symbolic representation. So I will just use a simple example to show you. There is something that you have to know, that there is difference between the frequency and atomicity. So I talk about H2O, right? So atomicity, that's the next thing I want to stress on. Atomicity. Atomicity is total number of atoms, right? Total number of atoms in a compound or molecule. So if you take this whole thing, right, how many atoms are here? The number of atoms are here. We have one oxygen. So O is here, right? H2O. And oxygen, the subscript here is 1. If it is 1, we don't write it. We don't write when it is 1. So the frequency of oxygen is 1, but the atomicity of water is 3. Atomicity is the total number of atoms. So hydrogen is appearing how many times? 2 times. That's the 2 here. And the oxygen is appearing once. It's here, but we don't write it when it is 1. So the atomicity of the atomicity of water is 3. The frequency of hydrogen in water is 2. The frequency of oxygen in water is 1. So it's just like the sum of all the frequencies inside an atom make the atomicity. So you say atomicity, right? Count all the number of atoms. How do you count the number of atoms? By looking at the subscript here, where F is, right? Sum all of them. Here is 2, here is 1. So here, the sum of all that will give you 3. That's the atomicity of water. And then let me say NaCl. NaCl is another example, right? Na is a symbol of sodium, and then Cl is a symbol of chlorine. So Cl, if nothing is written here, is 1 in 1, right? The frequency of sodium alone is 1. The frequency of chlorine is 1. But the atomicity of NaCl is what? 2. So the atomicity, the number of atoms inside is just 2. Basically that. Yeah. So that's the symbolic representation. Again, A is the atomic number. A is the mass number. Z is the atomic number. Atomic number is just basically the proton number, the P, right? Atomic number or proton number. O here is the oxidation number or the charge or the valency. Then we come to the F is the frequency. Because if you're talking about one atom alone, right, we're going to refer to the frequency. But if you're talking about the total number of atoms inside a particular whole molecule, then we call it atomicity. If you come to 1, so each of the atoms inside the molecule will contribute some number, So the number that each of them contribute is called the frequency of the atom. The frequency is how frequent that atom appears, right, in the molecule or in the compound. Atomicity is the sum of everything. So that's the difference between atomicity and frequency. Yes. So yeah, this is the thing that you have to know. You have to know the diagrammatic representation of the atom, and also have symbolic representation of the atom as well as the components. These are the very basic things, and we'll be using this term mostly moving forward. See you in the next session so that we can continue learning more.